Welcome to my lecture on partial fractions. Before I even get started, I just want to review a few things with you. So, things that I like to review is to first just recall the integral of 1 over u du is the natural logarithm of absolute value of u plus a constant. Okay. Let's try a little example of this. So if you were asked to integrate 1 over 8x plus 1 dx, you would do a u substitution with u equal to 8x plus 1. Then you'd work out by taking the derivative of that u substitution that dx is du over 8. So we integrate this with our u substitution. It becomes 1 over u times du over 8. Then upon anti-differentiating this, the antiderivative of 1 over u is going to be ln of absolute value of u, but then it's being multiplied by 1/8, and we add a constant. Finally, we back substitute to get 1 over 8 times ln of 8x plus 1 plus a constant. Okay. We can do similar types of problems, so they won't all be of the form 1 over 8x plus 1, but for instance, you might be asked to anti-differentiate 8 over x minus 1, and you should know how to do that. And in a similar process, you'll get 8 times the ln of x minus 1 plus a constant, and you'll do that by a u substitution with u equal to x minus 1, and pull the constant 8 outside of the integral. Okay. So you might ask yourself, why partial fractions? Okay. And before I do that, let me just back up and tell you about the general scenario of partial fractions, which is to integrate a rational function. A rational function has the form of p of x over q of x, where they're each a polynomial. Okay, so it's in the instance in which you have one polynomial divided by another polynomial. So for example, you could be asked to integrate 65x plus 7 divided by 8x plus 1 times x minus 1, all in the denominator. Okay, so in this example, that is a polynomial divided by another polynomial, and specifically this type of partial fraction has q of x, the denominator, is a product of irreducible linear factors. That's often referred to as non-repeating linear factors. It's also essential that the degree of the denominator, q, is bigger than the degree of the numerator, p. Okay, so our goal is to integrate the 65x plus 7 divided by 8x plus 1 times x minus 1. And our method is partial fractions. What partial fractions allows us to do is to write this polynomial as the sum of two other polynomials. Okay, so in this instance, hey, I can have 1 over 8x plus 1 plus 8 over x minus 1, and that's equal to my original term. So instead of integrating 65x plus 7 divided by 8x plus 1 times x minus 1, I can integrate each of those individual terms. And we integrated each of these individual terms above in the review. So hey look, we go back, we write down what the antiderivative 1 over 8x plus 1 is, and the antiderivative 8 over x minus 1. And it's what's here in the box, 1/8 times ln of 8x plus 1 plus 8 times this ln of x minus 1, and then we add a constant. So that's not too bad. Partial fractions makes integrating things easy, and that's the take-home message. But the big part of this section is identifying the type of partial fraction here. In this case, it's non-repeating linear, and then executing this partial fraction decomposition. So let's go through the how. How did we decompose this? Well, first, we needed to identify the non-repeating linear factors in the denominator. Okay, and once we do that, so if we start off with 65x plus 7 divided by this non-repeating linear factor of 8x plus 1 times by x minus 1, we want to decompose that into a constant a over one of the non-repeating linear terms, 8x plus 1, plus b over x minus 1. So this is our first step, and this is called the decomposition. That is the decomposition form. So it's very, very important to identify the right form. Our second thing that we'll do is we're going to clear the denominators. So I'm going to take 65x plus 7 divided by 8x plus 1 times by x minus 1. I'm going to set that equal to a over 8x plus 1 plus b over x minus 1. And I'm going to multiply both sides by the denominator, 8x plus 1 times x minus 1, and FOIL that result. So this entire thing gets multiplied by that, then there, and then by the leftmost term. Okay. So next, we're going to simplify. And upon simplifying, we're going to get 65x plus 7 is equal to a times x minus 1 plus b times 8x plus 1. Then I'm going to FOIL a second time. We just FOILed above, but now let's FOIL this other term. Okay. So we FOIL, I'm going to have a times x, and then a times minus 1. Then I'm going to FOIL the b's, and I'm going to have 8bx plus b. Now I'm going to rewrite this, and I'm going to rewrite this in this way. Hey, look, I have 65 times by x on the left-hand side. I'm going to gather all the x terms on the right-hand side. So that will be a and 8b. Okay, so that will be x times a plus 8b. And this is the x terms. Okay. Now next I'm going to gather all the constant terms. So it looks like that will be b minus a, and that's the constant term on the right-hand side. On the left-hand side, the constant term 7. So the next thing that we're going to do is we're going to equate terms. So hey, look, the constant term is 7 on the left-hand side. On the right-hand side, that's minus a plus b. Okay. Now the x term, that has 65 on the left-hand side. On the right-hand side is going to be a plus 8b. Okay. Now, the next thing that we need to do is we need to solve this equation. Okay. That is, we need to solve for a and b. Okay. So, fourth, we need to solve for the values of a and b. And there's two methods. We can substitute. That is, we could solve for the value of a in terms of b and then substitute it into another equation. Or we can do elimination. Now, normally I do substitution, but since this is so nicely set up for elimination, I'm just going to eliminate the value of a here. So I'm going to add the equations. And if I add the equations, on the right-hand side, the a's are going to cancel. I'm going to get minus a plus a to get 0a. Plus the b's are going to add to give me 9b. And on the left-hand side, I'm going to have 65 plus 7. So that'll be 72. So I think, I'm just going to take 72 is equal to 9b and then just do division. So b is going to be equal to 8. That solves that equation. Okay, now that I have the value of b, we need to figure out the value of a. So I'm going to use equation 1. And that says 7 is equal to minus a plus b, but I'm going to put b is equal to 8. So 7 is equal to minus a plus 8. Okay, then just by moving things to the other side, we can see a had better be equal to 1. So that's the value of a. And that tells us the partial fraction decomposition. It tells us 65x plus 7 over 8x plus 1 times by x minus 1 is going to be equal to 1 over 8x plus 1 plus b, which is 8 over x minus 1. And that's the partial fraction decomposition process. That's the how. Okay. Now, the integration we already did above. We integrated this, and that wasn't the hard part. The hard part was the process of figuring out the partial fraction decomposition. This type of partial fraction decomposition is called non-repeating linear. Thank you very much.